Welcome. I'm going to go over the homework step by step so you can see how I would do it. All right. I made a mistake and didn't say average velocity on the first one, so I apologize. But so here we go. So for an average velocity formula, I'm not going to go through the whole accelerated motion thing. I'm just going to list my data, right? So we're looking for the average velocity, okay? We know that the distance is 60 meters. That's also the displacement. There's a change, yeah. And the time is 3 seconds. Okay. All right. Now, when it uses the word average velocity, or if they don't mention acceleration or anything like that, okay, then it means you can use this really easy formula here. But just keep in mind that, focus again. Keep in mind that this is a really dangerous formula to use for accelerated motion. The reason is that average velocity, or v bar, is not the same as change in velocity, and people tend to combine these two things, and it's a bloodbath when it happens. All right, so since this is an average velocity formula, even though we didn't write that in the thing, we're going to use this formula here. All right, and so, yeah, this is just plug and chug at this point. 60 meters over 3 seconds, and that ends up being 20 meters per second. Okay, I did this just like I expect you to do on a quiz. I have a formula with no numbers in it. 0 does not count as a number. It could be like this or rearranged. Then I substituted in with units, and then I did my answer with units. And you can drop units in intermediate calculations if you like. Okay, now we have accelerated motion for the rest of these problems, right? So we're going to go ahead and do fill out our little data table. So it's VI, VF, DA, and T. Okay, so what is the acceleration? That is our unknown. And it's brought from rest. This is a key word that you should not ignore. It's brought to rest. That's the final velocity is 0. Excuse me. And then we have, this is an initial velocity because it started at 24 meters per second. And the time is 8 seconds. And remember, once you have 3 pieces of data and an unknown, you have enough to pick a formula. So we're going to go ahead and pick a formula here. We want something with with VI, VF, A, and T, but nothing else. All right. And our formula for this one is going to be, it's the formula. So you could either use this formula here, A equals change in V over T, or VF equals VI plus AT. These are the exact same formulas. I'm going to go ahead and use this one just to remind you, but realize that this expands to A equals VF minus VI over T. This is not on your, so whenever you're using this formula, you really need to expand it out to here or write out that the change in velocity is something. Okay, so I'm going to use that formula. A equals delta V over T. I'm going to expand it. A equals VF minus VI over T. And I'm going to sub in with units. So A equals, final velocity is 0, initial is 24, and the time is 8 seconds, okay? And then at this point, 24 over 8 is 3, so the acceleration is negative 3 meters per second squared, and it makes sense that it's negative because it's being brought to rest. Okay, now we have a jet, all right? So again, we're going to do VI, VF, D, A, and T. All right. Okay. It must reach a speed of 40. So this is a final velocity. All right. The acceleration is 3 meters per second squared. We are looking for the length of the runway. That's our unknown. And then since it's reaching this, the jet starts from rest. Okay. Notice I'm circling this. This is a good idea. This is good test-taking strategy if you have paper to work with. Okay, and now I have my 3 pieces of data and my unknown, so I can now pick a formula. Okay, so we want a formula that has these things in it and nothing that we don't care about, like time. This is the formula that doesn't use time. All right, so we're going to use that. VF squared equals VI squared plus 2AD. All right, I often just like to send, if a term is 0, I like to just do that and get rid of the entire term. So 0 squared is still 0. You could rewrite this as a working formula if you wanted. It's not necessary. But either one of these would be an appropriate formula to use, okay? And you could also rearrange this if you want. Some people like to rearrange the numbers first. Okay, 40 meters per second, don't forget to square it, equals 2 times 3 meters per second squared times d. All right, so let's do so 40 squared is 1600. I guess I knew that, but I'm going to drop units in the intermediate calculations. 2 times 6d. We're going to divide both sides by 6. And I get 266. So I get d equals 266.7 meters. Okay. Again, formula, substitution with units, answer with units. Okay. All right. Now, a train accelerates from rest at a rate of 1 meter per second squared east for 60 seconds. What is the final velocity? Here we go. All right, so I'm going to circle that word rest. We're going to make our little data table. All right. And let's see, it's accelerating from rest, so it tells us VI is 0. The acceleration is 1 meter per second squared. If you're wondering what things are, the unit tells us what it is. And actually, I'll provide a little unit sheet for you soon. Okay, to help with that. The time is 60 seconds, and we are looking for the final velocity. Okay, we have our 3 pieces of data and our unknown. We can now pick a formula. And the formula we're going to pick here is, the easiest one is this, which is really this rearranged, but like this is a better form. So use VF equals VI plus AT. And again, I'm just going to make this whole term drop out since it's 0. So then I'll substitute it. VF equals A, which is 60 seconds. No, that's not 60. Oopsies. A is 1 meter per second squared. And time is 60 seconds. So VF equals 60 meters per second. Some people might be having trouble with units. Let's just show how the units work out. So a meter per second squared times a second. Remember, really anything is really like a fraction over 1. Okay? This cancels with this, and you get meters per second. But the other reason you know is if the units all match, like you're using meters and seconds and yeah, meters per second, all that, the units will work out magically as well. All right, let's move this on. Okay, so Victoria drops a watermelon off the roof. Let's make our data table. Okay, the roof is 9 meters tall. I'm going to make a sketch. So here's the high school. Here's Victoria. Here's her watermelon, and it's going to go splat. Okay. All right. We want to know it's VF down here. Okay. And this distance here is 9 meters. Okay. All right. Now, I'd said before that it's a little bit intimidating to do a freefall problem because there's one piece of data, and that seems like too little, but everything else is hidden, okay? This word drops, she's not throwing it down, she's dropping it. That tells us her initial velocity is 0, so that's the first piece of hidden information. Now, the next is that since we are close to the surface of the Earth, you can use acceleration due to gravity, and that's 9.81 meters per second squared. Now, one thing we've been a little bit sloppy with on this homework sheet is direction. So if we decide this is the negative direction, we need to change some of these numbers, right? This is a negative 9.8. As long as down is negative, acceleration due to gravity is going to be negative. And the distance the watermelon travels is also negative. Now, you could say up is the positive, or up is the negative direction, and down is positive, and it would clear this up. But in general, when I do problems, I'm going to always do it as if it's down is negative just to be consistent. Okay, and we are looking for the final velocity. So now, even though they only gave us one thing, we're up to our 3 pieces of data and our unknown. So we can pick a formula. And again, this is the formula that doesn't have time in it, which is this last one. All right, so here we go. VF squared equals VI squared plus 2AD. All right, VF, that's our unknown. All right, VI is 0, so I'm going to get rid of this whole term. So VF squared equals 2 times negative 9.81 times negative 9. All right, so when we do the math there, we get VF squared equals, 2 times 9.81 times 9. And we get that VF squared is 176.6. I'm dropping units here. Now, all right, so then we got to take the square root of both sides. Now, if you forgot to make one of these negative, you might find yourself trying to take the square root of a negative number. If that happens, it means you forgot a negative. Don't stop doing the problem. Look for where you forgot a negative and fix it. And then the brute force way of doing this is to say, well, I can't find where I messed it up, so I'm just going to ignore the negative. And if that's what you need to do to get your answer, then that's what you should do. All right, so I'm going to square root that. And I get that the final velocity is 13.3 meters per second. Now, remember when you take the square root of both sides, technically you're supposed to put a plus and minus in front of it. And that's for math. It could be easy one. In physics, only one of those answers is going to be right. So since down is the negative direction in my example, you have to decide whether it's positive or negative. It makes sense. So technically, this is a negative final velocity. Okay? All right. I'm going to move to the next page. All right. Let's see how we're doing here. Okay. All right. Okay, the world record for successful cliff diving is 58 meters. So again, we're going to do our thing. VI, VF, D, A, and T. Okay, so 58 meters. So again, we have a cliff. I'm going to make it good and cliff. And then we have a cliff diver. Okay, and he's going to splash. Okay. And this distance here is 58 meters. Okay. We want to know the time. That's our unknown here. All right. Again, I'm going to say, to be consistent, that down is the direction. Negative direction is down. All right. So, again, intimidating because we have one thing, and that's 58. But since the actual diver is moving down 58, I'm going to put that in as negative. Okay. Now, with a dive, you have to assume that the initial velocity is 0 because he's going off here, okay? Even when people dive, even if they give themselves a little sideways velocity, they don't give themselves down velocity. All right. And then, again, since we're close to the Earth's surface, whoops, that's not the one. Acceleration due to gravity is 9.81. And since we're saying down is the negative direction, I'll make that negative. All right. And we've got our 4 things. We've got our 3 pieces of data and our unknowns. We are ready to pick a formula, okay? So the formula we're going to use is this is my favorite. D equals VIT plus 1/2 AT squared. Okay, so D equals VIT plus 1/2 AT squared. Again, since the initial velocity is 0 and 0 times anything is 0, this whole term drops out. So this is the working formula. And if you rearrange this first, that would also be a working formula. But you need one of these formulas or a rearranged version on a quiz or a test. Okay, so let's see. Negative 58 meters equals 1/2 times negative 9.81 meters per second squared time squared. All right. Let's see. So I've got negative 58. I'm dropping units. Half times 9.8 is 4.905. I'm not gonna be that accurate. T squared. All right, and then divide both sides by 4.9. And you get that T squared, whoop, equals whatever 58 over 4.9 is. It's 11.8. And then I need to take the square root of both sides. Again, if you forgot a negative, you might find yourself trying to take the square root of a negative number. It means you forgot one, so go back and try to figure out where you forgot it. But if you absolutely can't, the brute force is ignore the negative. All right, so when I square root that, I get the time is 3.4 seconds. Okay, now we want to know how fast he's going, and we have a choice of formulas, but I am not going to use my intermediate value, and the reason is that if I made a mistake here, I'd compound it. But on a quiz or a test, that wouldn't hurt you. You can use a wrong answer here, and you would get full credit on the second part. Okay, so what do we need? I'm going to use this formula, the one without time. VF squared equals VI squared plus 2AD. And again, that drops out. So I get VF squared equals 2 times negative 9.81 times negative 58 meters. And I'm not going to go through all the math here, but when you do this, well, actually I am in case you didn't watch the other one. All right, so I'm going to do it. So let's do this. So I get VF squared equals 1,137.96. That's ridiculously accurate, but whatevs. And then, again, if you didn't forget a negative, then this should end up being positive, because 2 negatives makes a positive. So I'm going to take the square root of that, and I get that the final velocity is 33.7 meters per second. And again, when you take the square root of something, you have to put a plus and minus in there. The plus or minus, again, because he's hitting the, about to hit the thing, it's this. All right, and then finally, all right, Xander throws a ball with a velocity, so I'm going to do our data table, VI, VF, DAT. And we're shooting, so what's happening is Xander is shooting a ball. It's going straight up and coming back down, okay? And the initial velocity is 20 meters per second. And we're going to say up is positive direction, like I'm always going to do to be consistent. All right, what height does it reach? We're looking for that. And acceleration, again, we're close to the surface of the Earth, so we're going to use this. And it is a negative acceleration. Even though the ball is going up, it has a negative acceleration because down is the negative direction. All right. And it's causing a slowing change on the way out. That's the other reason. All right. We want to know the height. We need one more piece of information, and that comes from right here. The velocity at the top is 0. There has to be this moment in time where the ball stops, okay? Again, if we looked at a graph of this for velocity time, it would look like this. And right there, it stops and turns. So there has to be a moment. So VF equals 0 at the top. Okay, and we want to know, and that's also when we want to know the height, okay? All right, here we go. Let's see. What am I going to do here? Time equals. All right, so I have my 3 pieces of data and my unknown, so I need to pick a formula. I'm going to pick the formula that doesn't have time in it. VF squared. I'm just checking my key to make sure I'm not making some dumb mistake. Equals VI squared plus 2AD. All right. This is 0 because it's 0 at the top. So 0 equals 20 meters per second. Don't forget to square it. Plus 2 times negative 9.81 times D. All right, so 0 equals, I'm dropping units, 400 plus, actually I gotta say minus 4.9D. So now what I gotta do is I gotta pull the 400, I gotta subtract 400 from both sides. So I get negative 400 equals 4.9D. Divide both sides by 4.9. And I get that I screwed up somewhere. What did I do? Oh, I know what I did. I did the new math. Safe place to make mistakes. Do it all the time. 2 times 9.8 is not 4.9. It's negative 19.6. Okay. I know I can do this in my head, but I can't always do it when I'm performing. Alright, so now let's screw this up again. Alright, so then I'm going to carry my mistake down here. So negative 19.6D. Sorry about that confusion. Okay, so divide both sides by negative 19.6. This cancels, and I get time, or distance, equals 20 meters. And that is, yeah. So what that means is the time it took to get to the top is, or the distance it made to get to the top is 20. Okay. I think we're going to need some more practice on this stuff. All right. And that's what we're going to call it a quits.